Welcome students to the ACT Help video part 2. We will look at numbers 11 through 20 during this video. Probably at the start of every video I will give this disclaimer. Please remember I do know how to spell, however my typing ability is not the best, so if we see any typos, misspellings, we're just going to keep moving on and not really pay a whole lot of attention to those, so please keep that in mind. Remember, I do try to go fast on purpose because you can always pause the video and back it up, but you can't always speed it up, so I am going to go pretty fast. Okay, number 11. At the winter weather store, the price of one hat is $12 and the price of one scarf is $14. Jovan spent $128 to buy 10 items. Now when they say 10 items, they mean a combination of hats and scarves. It could have been 6 hats, 4 scarves. Could have been 3 and 3. We don't really know. How many hats did he buy? Now, this is like a previous problem we did on part 1, in which we have 2 unknowns. Now let me pause right there and say, I know that it's just asking how many hats did he buy. I get that, but really it's 2 unknowns. I mean, we're dealing with hats and scarves. So right away I notice we're dealing with 2 unknowns. And so I'm going to need 2 equations here, just like the problem we did in video part 1, okay? And so as I look at this, I'm thinking to myself, okay, one way to do this is trial and error. I could try 0 and 6, and then 1 and 5. And then, actually, I'm sorry, it was a total of 10 items, wasn't it? Okay, my bad. So it could be 1 and 9, 0 and 10, 3 and 7, and we could try trial and error. We really could, okay? But there's a much better way to solve this problem. If I have 2 unknowns, let's come up with 2 equations. And number 2, let's remember to look for totals, okay? Totals. For example, he spent a total of $128. He bought a total of 10 items. Now looking for a total won't always work, but quite often it does. So I'm going to say H is my number of hats and S is my number of scarves. So if I add up all of my hats and scarves, I come up with a total of 10 items. Doesn't that make sense? All of my hats plus all of my scarves equals 10. Now, each hat that I bought, and I'm not sure how many I bought, but each one should get multiplied by $12 because of this phrase right here. And every scarf that I bought should be multiplied by $14. And we get that from right here. And if I take all of my hats times 12, all of my scarves times 14, it should add up to what I spent, which was $128. Now, students, I'm going to very quickly try to do this problem 2 different ways. Now, if you know how to finish the problem from here, then fast forward the video to the next problem. That's fine. That's what this video is all about. You don't have to sit there and listen to something you know how to do, okay? But there's 2 different ways now to solve this system. There's actually more than 2 ways, but one way would be substitution and another way would be linear combination. Let's first of all deal with substitution, all right? So here we go. Did not mean to do that. There we go. Okay, let's deal with substitution. Do you see this equation? H plus S equals 10. If I brought the H over and made it a negative H like that, I would then have this right here. I would have S equals 10 minus H. So S equals this whole expression. So I could then substitute that in for S right here. So if I did that, I would then have 12H plus 14 and then parentheses, because what's beside the 14? An S, and I would then substitute 10 minus H equals 128 and then solve this quickly. Take your 14 and distribute it through the parentheses. 14 times 10 is 140. 14 times negative h is negative 14h equals 128. Next, I would combine my 2 h's. Positive 12 and negative 14 is negative 2 h, and I would bring my positive 140 to the other side, and when I brought it over I would make it a negative 140. So 120 minus 140 would be 12. And then, or excuse me, a negative 12, I apologize, negative 12, and then divide both sides by negative 2, and we know that a negative divided by a negative is a positive, so there we go. He bought 6 hats. Now, is that what it's asking for, or scarves? It's asking for hats, so there, we're done, 6 hats. No, that's one way to do it. Another way to solve this system would be to use linear combination. For example, I notice that I have a 12 here and a 14 here. So if I could somehow get a negative 12 right here beside this h and then add these two equations together, my h's would cancel. Now you should have had this in Algebra 1 and Algebra 2. I'm going to take my top equation and I'm going to, hold on, my mouse is freezing up here. Hold on one second. There we go. I'm going to take my top equation right here and I'm going to multiply that by negative 12. So negative 12 times h is negative 12h, negative 12 times s is negative 12s, and negative 12 times 10 is negative 120. And then I'm going to bring down my bottom equation, 12h plus 14s equals 128. And now let's add these two equations together. These cancel. A negative 12 and a positive 14 is 2s equals negative 120, positive 128 is positive 8. Divide both sides by 2, and the number of scarves that I purchased is 4. Now the only problem with that is that's not what they asked me. They asked me how many hats did he buy. So I know he bought 10 items altogether. So if he bought 4 scarves, then I know that he bought 6 hats, which is the exact same answer I got here. So what are they trying to teach you in this problem? How to set up a 2-variable linear system from a word problem and solve it. That's what they're trying to teach you, okay? So the answer would be letter D for number 11. Okay, let's move on now to number 12. Square ABEF, I'm going to highlight it for you, ABEF right there, and parallelogram ACDG, so there's your parallelogram, I highlighted it for you, are shown in the figure below. Points E and F are on DG, so this is all one line right here, which is pretty obvious. And B is on AC, which that means this is whole one line here, which that's pretty obvious. And the lengths given are in inches. So we have 5 inches here and 7 inches here. What is the ratio of the area of ABEF, that's my what? That's my square, to the area of ACDG? And of course, what is that? That's my parallelogram. Now, don't forget what ratio means. Ratio means a fraction, or you can use dots like this also. That's fine. I'm going to use a fraction for right now. So the final question is, what is the ratio of, are you ready? The area of my square, that's what it says. What is the ratio of the area of ABEF to the area of my parallelogram? So that's my goal. I'm going to find the area of the square and put it up top, find the area of the parallelogram and put it in the bottom. So what are they wanting you to prove that you know in this problem? First of all, they want you to prove that you know what ratio means and how to set up a ratio. That's number 1. Number 2, they want you to prove that you remember some of your old trigonometric or geometrical area formulas. For example, let's review some of these. You can quickly write them down. Area of a triangle is 1/2 base times height. You might want to write that down so you have it to memorize before your test. Make sure you know that. Area of a triangle. I'm not going to put triangle. You can put triangle yourself. Area of a trapezoid. That's interesting. 1/2 times the height, and then B1 plus B2. That's one that could be on there. That's not very common. So, area of a circle. Do you remember that one? Pi r squared. Okay, here's some areas. Of course, area of a rectangle, we know that. Length times width, area of a square, length times width. But here are some shapes that you might not have thought about. Write those down and make sure you know those, because on the test, they can ask you any question about these normal geometric shapes. Okay, now let's continue on. So we have to find the area of the square and the area of the parallelogram. Let's first of all, oh, by the way, what's the area of a parallelogram? Sorry about that. I forgot to give that to you. Area of a parallelogram is base times the height. Base times the height. So write that down. Area of a parallelogram. Okay. So let's start off first of all with the area of our square. Well, I know the length from here to here. I'm going to change colors. I know the length from here to here is 5. And I know if this is a square, which look, it says square right up here. So I know if this is a square, then all the sides are the same. So I know this is a 5 also. So I can find the area of the rectangle or the square pretty easily. So the top of my fraction is 25. 5 times 5. That's pretty easy. Now let's take a look at finding the area of the parallelogram. How do you find the area of a parallelogram? Well, base times height. Now let's think about this for a second. If this whole length all the way across is 12, which it is, right? 5 plus 7. So if this whole length across the top here is 12, then doesn't that mean this whole length down here is also 12? Sure it does. So I know my base of the parallelogram is 12. Now the height is a line that goes straight up and down perpendicular, forming a 90-degree angle right here. Goes straight up and down. Well, look, I've got that right here. I mean, this line right here, 5, would also be the length of this line here, 5. So I know my base is 12. I know my height is 5. So my entire area is 60. So the ratio is 25 to 60. Of course, we have to reduce that. And 5 will go into both of those numbers. So 5 over 12. And if you'll look at your answers, they want you to write it with a colon. And so your final answer would be 5 to 12. 5 to 12. All right, let's take a look at number 13. Which of the following graphs shows the solution set for this inequality? Well, we're going to have to solve it, okay? Pretty simple. So I'm going to take my negative 5, bring it to the other side, and make it positive. So when I bring it over, I would have 7 plus 5, which is 12. And now divide both sides by 6, and x is greater than, I forgot my equal sign here, x is greater than or equal to 2. So what that means is you want a number line, and your critical value is 2. So here's 0, here's 1, here's 2. Notice it says x is greater than or equal to. When it's equal to, you do shade in the point. And then it says x is greater than. Well, I don't want to go, it's saying x is all of the numbers greater than 2. I don't want to go this way. Those numbers are less than 2. They're smaller than 2. I want all the numbers greater than 2. So I go to the right, or how they have it there in the picture is like this. Okay? Now, let me give you a couple of thoughts in case they might throw these curveballs at you on the test, on the ACT test. What if there was no equal sign? What if it just said x is greater than 2? Well, then don't shade this point in right here, okay? Leave it empty and just go like that, all right? I have another question for you guys. I hope you're listening to all this, please. What if it was a negative 6? Do you remember that when you divide an inequality by a negative number, you turn the arrow? You turn the arrow. See how the inequality symbol was facing to the right and now it's pointing to the left? That's because I divided by a negative number. Now, if you divide by a positive number like we did earlier, we don't turn the arrow. But if you divide by a negative number, you turn the arrow, okay? So, anyways, back to the original problem that we had, or the original answer that we had before I did all these changes. What we had was x is greater than or equal to 2. So let's see. It's not this one, it's not this one, it's not this one, it's not this one. It's got to be letter B right there. X is greater than or equal to 2, all right? All right, let's take a look here. The length of a rectangle is 5 inches longer than the width. The perimeter, that means counting all of the sides all the way around, the perimeter is 60. What is the width of the rectangle? Now, please don't freak out in the test. You just very quickly, remember our phrase, we work quickly, not hurriedly. So we quickly draw a rectangle. The length is 5 inches longer than the width. So I'm going to call the width here, look, I don't know what the width is, so I'm going to call it W for width. Okay, now what's the length? I don't know, but I know it's 5 more than the width. So if I take the width and add 5 to it, would that not be my length? Sure it is. Look at it. The length of a rectangle is 5 longer than the width. So if I call my width W, then the length is W plus 5. What if I called it X, Mr. Earhart? Then it would be X plus 5. It really doesn't matter what variable you use at all, as long as you're just consistent throughout the problem. So, now I have a question for you, math scholars. You know how a rectangle has opposite sides congruent. So if this is W, what's this side over here? W. If this side is W plus 5, what's this bottom side going to be? W plus 5. And I know if I add all four sides together, I get the perimeter. And what is the perimeter? They gave it to me, 60. So if I take one side, W, check, plus this side, W plus 5, plus this side, plus this side, that's the perimeter, and the whole thing equals 60. So here we go. W plus W plus W plus W. Don't forget there's a 1 in front of each one, okay? So 1 plus 1 plus 1 plus 1 would be 4W, and then 5 plus 5 would be 10. Remember, you can only combine like terms, okay? You cannot combine unlike terms. Okay, now we bring the 10 over, and when we bring it over, it becomes a negative 10. So this 10 is now gone. We're going to cross it off and put a negative 10 right here. And so I'm left with 4W equals 50. Now with a calculator, divide both sides by 4, and you should get, let's see, 1, 2, I think 12.5 is correct. 12.5. Is that right? I believe that's right. 1, 4, 10, 2, 8, 25. Yep, 12.5. So there we go. W is 12.5. Now, please be careful, students. Please be careful. They could have tried to trick you on this. You do all of your work and you see that W is 12.5. But did they ask you for W? Well, maybe, maybe not. Look at the question. What is the width? Well, this is the width. And what variable stands for the width? W. What does W equal? 12.5. So we're good. There's the answer. No problem. But what if they would have asked you for the length of the rectangle? Okay, no problem. What's the width? 12.5. What do we have that represents the length? W plus 5 right here. The length of this rectangle is W plus 5. So where the W is, you would put 12.5 plus 5, and you would get 17.5. So just, I know they didn't do that to you, but I'm trying to give you more than just working out the problems. I'm trying to give you some thoughts in which you can look at it and say, in which you say to yourself, well, they might try this on the test, they might try that. And that is something they might have asked you for. Instead of asking you for the width, they might have asked you for the length. So be careful and always know what they're asking for in the problem. Okay, now we're going to use this picture here for numbers 15, 16, and 17. Okay, so let's read through this real quick. Miriam conducted a survey of the students in her 8th grade class. She wanted to determine which of the 7 Olympic sports were the most popular. Each student who responded selected one sport as their favorite. The circle graph below shows the number of students who selected each of the 7 Olympic sports. A total of 40 students responded to the survey. Okay, so the total altogether should add up to 40, and I'm sure that it does. Now we're going to use this for numbers 15, 16, and 17. So here we go. Here's question number 15. To the nearest 0.1%. Now please don't let that freak you out. That just simply means round your answer to 1 decimal place. That's all that it means. Nothing else, guys. Nothing else, okay? To the nearest 0.1%, what percent of the students who responded to the survey selected basketball? Now, it doesn't say how many selected basketball, what percent. Let's go back and look, okay? Basketball. Here it is. 10 students selected basketball. Now, how many total students were there? 40. So hopefully you know by now when you're looking for a percentage of something, you put the possible number in the bottom or the total, whatever word you like to use, and up top we put the actual number. So the actual number that liked basketball would be 10, or that chose basketball. The possible that could have chose basketball was 40, or if you like to use the word total, that's a good word also to use, that's fine. So 10 over 40. Now with your calculator, notice your answers are not a fraction, they're in a percentage. So with your calculator, I want you to divide 10 by 4, and you'll get, type in 10 divided by 4, and you'll get 0.25. And then remember, when you have a decimal and you convert it to a percentage, you're going to move the decimal 2 places, okay? 1, 2. And let me glance very quickly here. Yes, when I typed this, I did not cut and paste this out of the answer book. I typed it. Here's a typo right here, and I apologize. Letter D is supposed to be 25%. So would you fix that real quick? Sorry about that. Okay, so if you're converting 0.25 to a percent, you move the decimal 2 places to the right, and your answer is 25%. Now, so there's your answer, letter D, 25%. Now, what are they trying to teach you in this problem? Well, first of all, they're wanting to know if you know how to find a percent. Actual over possible, actual over total. Also, actually, it should be 25.0, and that's the next point I want to make. It should be 25.0 because it did say to round to 1 decimal place. Now, you can call that annoying and picky all you want to, but I'm just trying to get you ready for this test, okay? So really, it'd be 25.0%. So they wanted to make sure you knew how to round correctly, and they wanted to make sure you knew how to take a fraction, change it to a decimal, and change it to a percent. All basic math. All right, number 16. In this survey, what is the ratio of the number of students who selected athletics to the number of students who selected soccer? So ratio, we got a fraction. We're going to put athletics up top and soccer in the bottom. So here we go. Let's go back a page. Let's see. How many chose athletics? 9. How many chose soccer? 5. So the ratio of those who chose athletics to those who chose soccer would be 9 over 5. You cannot reduce that. So we write it 9 to 5, which would be letter H. Okay? All right, moving on. Number 17. Oh, this is going to be a good one here. Now, please pay attention. In the circle graph, what is the measure of the angle? They want you to find the measure of an angle of the sector that represents the number of students who responded to the survey who selected tennis. So let's take a look at this. Here's tennis right here, a real small sliver of the pie, okay, of the circle graph. Only one student chose tennis, okay? Now, how are we going to find the angle measure of that? Well, students, I would like to tell you how we're going to do it, okay? First of all, remember, in a circle, there's always 360 total degrees. So if I were to start here and have an angle that went all the way around to, like, let's say right here, I'm going to change that. Let's say I'm going to change that a little. Let's say I started here and went all the way around to right here. That means I traveled 360 degrees. I went all the way around. So watch what I'm going to do here. Can I show you something, please? Now watch this carefully. I know that one person chose tennis. But what does that mean? That means this little sliver is 1/40th of the pie. Whoa, Mr. Harrod, where'd that come from? Well, hold it. Now watch this. This should make sense. If I ask you what fraction, let's go back a problem. Back here they said, remember, they said what percentage chose basketball, and I said 10 over 40 because that was actually 10 and total 40. In the next problem here, we said the ratio was 9 to 5, 9 compared to 5. Well, look, if one person chose tennis, that was 1 out of how many? 40. So the fraction that I have is 1/40th. Now, please watch this. That's 1/40th of the whole what? The whole circle. Do you see that okay? Does that make sense? This little sliver is 1 out of 40 people. So that little sliver is 1/40th of the whole circle. Now, if it's 1/40th of the whole circle, what does the word of mean in math? Multiply. What's the whole circle? How many degrees? 360 degrees. So you should be able to use your graphing calculator, okay? And you should be able to type in 1 divided by 40 times 360. And if you do that correctly, or we can do it together right now if you want to, put 360 over 1, and you can cross cancel. 40 goes into 40 once, and 40 goes into 360 9 times. 1 times 9 is 9. 1 times 1 is 1. 9 over 1 is 9. So it's 9 degrees. Let's go over this again. What fraction was this little sliver right here? 1/40th, 1 out of 40 people. Okay, now I want you to find the angle measurement. Okay, this is 1/40th of the whole circle. Of means multiply, and the whole circle is 360, so 1/40th times 360. You do get 9 degrees. And so the correct answer for 17 would be letter D, 9 degrees. Okay, now what are they trying to teach you here, or what are they trying to test you on here? A lot of stuff. They want to see if you can understand circle graphs. Can you find the fraction of a part of a circle graph, or a sliver of a circle graph? Can you correspond that over 2 degrees? For example, what if they would have asked about basketball? Can you tell me what this angle right here would be in basketball? Well, sure, I can tell you what that, sorry about that. Let's go like that, and let's go back a page. Yeah, I can tell you what that percentage would be right there. Certainly, I would say 10 people chose basketball out of 40. So that sliver is 10/40ths. Reduce that, it's 1/4. And I would take 1/4 times 360 degrees, and I would get 90 degrees. So they're trying to test your ability to take a sliver on a circle graph, find the fraction of it, find the percentage of it, and also find the angle, the central angle measurement. Okay, all right, let's take a look at number 18. A spinner dial from a game is shown below. Each numbered sector has the same central angle. In other words, what they're saying there is there's no space bigger than another. All of these spaces are the same, so every number has the same chance of being landed on. Okay, all right, let's continue on. If the arrow on the spinner dial is spun, so it's spinning around, what is the probability the arrow will land, or will point to a sector, or land on a number whose number is both a multiple of 3 and a multiple of 4? Okay, so for example, let me show you. The number the spinner lands on has to be a multiple of 3 and a multiple of 4. So let me use 24 for an example. Okay, all right. 24 is a multiple of 3 and 4. How do I know that? Because 3 goes into 24, we know that, 3 times 8, and 4 goes into 24, 4 times 6. You know how we can say this? Are you ready? We can say 3 and 4 are what? Factors of 24. Or we can say it backwards. We can say 24 is a multiple of 3 and 4. Let me go over that again. 3 and 4 are factors of 24, or we can say 24 is a multiple of 3 and 4. Either way, the bottom line is this. We're looking for numbers over here that 3 and 4 both go into evenly. So I'm not sure why I erased that. 24 is one of them. 64, 3 doesn't go into 64, 3 doesn't go into 22, 3 doesn't go into 32, 4 doesn't go into 6. Here's one. Doesn't 3 go into 12? Yes. Doesn't 4 go into 12? Yes. 4 doesn't go into 18, but guess what? 3 goes into 36 and 4 goes into 36 too. 4 times 9 is 36. So I have found 3 numbers who are multiples of 3 and 4. So here's the question. Are you ready? What is the probability the arrow will land on one of these 3 numbers? Well, let's see. Let's find out. Let's see here. Hold on one second. I think I've hit something I should not have hit. Hold on. Okay, I'm back. Sorry about that. My computer did some weird stuff there. Okay, anyway, so the 3 numbers I circled were 24, 12, and 36. Now, those 3 numbers are all multiples of 3 and 4. Now, that means, what's the probability that the arrow will land on one of those 3 numbers? Well, let me ask you a question. Let's use this formula again. What are the actual numbers that I'm looking for over the total or the possible numbers? Well, the actual numbers I'm looking for would be 3, correct? There's 3 possible numbers the spinner could land on out of how many total numbers altogether? 3/8. So the 3/8. So the probability that the spinner will land on one of these three numbers is 3/8, or 3 out of 8 is another way to say it. The probability is 3/8. Now, would you please listen to me? I don't want to scare you, but I want to prepare you for the ACT test. What if they hadn't said probability? I'm trying to give you all kinds of thoughts. What if they would have said, what is the odds the arrow will point to a sector? In that case, I've always used this little phrase. I've told my students, if you're talking about odds, it's the actual over the leftovers, or the extras, if you will, however you want to say it. Okay? So, if they would have asked for odds, what is the odds the arrow will point to a number who's the multiple of 3 and 4? Well, the odds would be, what's the actual numbers that you have? 3. And then how many are left over that you didn't use? 5. You used 3 and you didn't use 5. So the odds would be 3 to 5. Do you see the difference? If not, back this up and listen to it again. So if they ask you for the probability, then it's the actual number over the total. 3/8 or 3 out of 8, 3/8. If they ask for odds, it's the actual number over the leftovers. You would say the odds are 3 to 5. There is a difference there, so please understand that. Okay, number 19. The counselors at Lakewood High School interviewed 200 students to determine placement in 3 different honors courses: math, chemistry, and literature. The number of these students placed in these honors courses are shown in the Venn diagram below. Of these 200 students, 10% were placed in all 3 honors courses, 35% were placed in 2. What percent of the students were placed in exactly 1 honors course? Now, what are they testing you on here? First of all, excuse me, sorry, I'm going to grab a quick drink of water. They're testing your ability to read a Venn diagram. In other words, these 15 are all by themselves in the math class, these 20 are chemistry, these 65 are literature. Do you see how 35 is in 2 circles? Watch, I'm going to kind of shade it in for you here. 35 is not anywhere in the chemistry circle, is it? It's not, but it is in these 2 circles right here. So 35 students took math and literature. See how this 25 right here, that 25 area is shaded right in here? Do you see that? If I shaded that 25, do you see how that 25 falls nowhere in the math circle? Do you see that? So that means those 25 students took chemistry and literature. It's in those 2 circles. Same thing with 10 right here. This number 10, if you were shading that area with a number 10, notice it would go nowhere in the literature circle. So that means these 10 students right here were in both math and chemistry, both honors courses. Well, there's only one place up here that if I shade it, it's in all 3 circles, and it's that 20 right there. It's in this circle here. It's in this circle here, is it not? Sure it is. And it's in this circle here, isn't it? Sure. So this 20 right here is in all 3 circles. That means how many students were allowed to enroll in all 3 honors courses? How many? 20. Now let's read the question again. What percent of the students were placed in exactly 1 honors course? Well, there were 20 students. Remember the formula I gave you when you're trying to find a percentage? It's usually going to be the actual over the total, or the actual over possible. So the actual amount of students that took all 3 classes was 20. Over how many total students were there? I circled it for you earlier, 200. Okay? Now with your calculator, type in 20 divided by 200, and what you will get would be, let me look at my answer sheet real quick here. Okay, I am back, students. I was looking at my answer sheet, and you know what? I'm in a dilemma here. I care about y'all, but I am not going to start an entire video over. It's taken me about 40 minutes so far, 30-40 minutes to make. Everything I've taught you is perfect. However, I misread the question. You're probably thinking, man, Mr. Earhart, you probably noticed right at the beginning, whoo, you need glasses, and I probably do. Maybe I need a brain, I'm not sure. But I am so sorry, but I am not going to redo this whole video. And if I was on problem 1 or 2, I would, but I've got 1 more left. So I misread this last question. I'm so sorry. It does not say what percent of the students were in all 3. It said It says what percent of the students were placed in exactly one class or one course. I'm so sorry for misreading that and messing it up, so please forgive me. Okay, in mathematics, how many students took mathematics only? 15. 15 students. Notice that number 15, if I were to shade that in, it doesn't fall in any other circles. 15. In chemistry, how many took chemistry only and none of the other honors courses? 20. Notice how if I shade that area in with a 20, notice how that doesn't fall in any other of the other circles. And then how many students took literature only that did not take any of the other honors courses? 65. If I were to shade in this 65 area right here, notice how it doesn't fall in any other circles. I'm so sorry, guys. I apologize. So we had 15 that took one course only. We had 20 that took one course only. We had 65 that took one course only. If you add those up, you will get a total of 100. And again, I'm really embarrassed and sorry that I messed up like this. So how many total students took one course only? Do you see it? 15, 20, and 65. 100. So what percentage of the students took one course only out of these three? Well, 100 did. Out of how many? Out of 200. And so if you reduce that, just go ahead and take your calculator and type in 100 divided by 200, and you'll get 0.5. Then remember, if you convert a decimal to a percentage, you move the decimal 2 places. So 0.5 is the same thing as 50%. So the answer to this would be 50%. And for the third or fourth time, I apologize. I wish I could back up the future, back up to the past, and redo it, but I can't. So I'm sorry. Okay, one more problem and we're finished. Okay, one more problem. Number 20. One sign flashes every 4 seconds and another sign flashes every 14 seconds. At a certain instant, the two signs flash at the same time. Now, how many seconds will elapse between until the two signs next flash at the same time? Okay, number 20 says, one sign flashes every 4 seconds and another sign flashes every 14 seconds. At a certain instance, the two signs flash at the same time. How many seconds elapse until the two signs next flash at the same time? Now, there's two different ways to do this. And we're going again, we want to be quick but not hurriedly, work quickly but not hurriedly. So one way is a little faster than the other. They're both good ways, but this is a pretty tough problem. You stop and think about it for a second. First of all, you can use common sense. We're going to call it light number 1 and light number 2. Now let's say they both just flashed at the same time. Boom, check. As soon as they flash at the same time, this light flashes every 4 seconds. So 4 seconds, so I'm going to put a colon here and a colon here. So every 4 seconds, so 4 seconds later, this one flashes, then 4 seconds later, and then 4 seconds later, and then 4 seconds later. So I'm going to list a bunch of these out real quick. I mean, if I wasn't explaining this to you and just writing, I could go a lot faster, okay? So there we go. Every 4 seconds, the light flashes. So from when it last flashed, from when these two lights last flashed together at the same time, it's been 4 seconds, then 8 seconds, then 12, then 16, then 20. Every 4 seconds, this light flashes. Now down here, this light flashes every 14 seconds. So 14, 28, 42. I'm going to stop right there. I can stop. I found my answer. Right here, look. Look at this. 28 and 28. So after they both flashed at the same time, light number 1 is going to flash 28 seconds later. Light number 2 is going to flash 28 seconds later. Now the difference is this one flashed how many times? 1, 2, 3, 4, 5, 6, 7. This was only flashed twice, but it doesn't matter. 28 seconds later, they're both going to flash at the same time. Some of you might get this, some of you might not, but that's how you would do that. Now, there's another way to do it, by the way. Can I show you something, please? We're dealing with what? One light flashes every 4 seconds, and one light flashes every 14 seconds, correct? Now, let's just think about this for a second here. If one light is flashing every 4 seconds and the other light is flashing every 14 seconds, do you notice how 28 is a multiple of 4 and 14? 28 is a multiple of 4 and 14. Okay, now I've got a thought for you. Why this is really cool. Watch this. Another way, and that was probably a really easy way to understand, but another way to do this is simply think of it this way. One light is flashing every 4 seconds. Another light is flashing every 14. Let's find the least common multiple. So remember how to do that? The factors of 4 would be 2 and 2. The factors of 14 would be 2 and 7. And now remember how to find the least, that's a C right here. Remember how to find the least common multiple? You look for pairs, common numbers going back and forth, and if you find a common number, you only write it once. So here's a 2, here's a 2, only write it once. Here's a 2, there's no 2 over here, so we bring that 2 down, even though it's only once, that's okay. And then anything left over here, we also bring it down, and there we go. So 2 times 2 is 4 times 7 is 28. So what that means is the least common multiple, or the smallest multiple, or the multiple that will happen the fastest is 28. So this light's flashing every 4 seconds, this light's flashing every 14 seconds. The number that's going to come up the quickest that both of these numbers go into, 4 and 14 both go into, is 28. That's another way to do it also. Okay, hopefully that makes sense. And again, not everyone's going to understand every problem that we do, but hopefully it's helping you think a little bit and use some reasoning skills. Okay, so with that in mind, I hope that's been a help to you, and go ahead and look to use part 3 whenever you are ready to.